I'll be your lecturer, Dr. Anastasia Damini. And then if you have any questions regarding the work, you'll send me an email to lamia@unisa.ac.za. And if you have any other questions, what's this regarding the work itself, not something else, please. And please note that if you send me an email, use your MyLife email address. If you do not use that one, then I will not respond to you. And if you send me an email and I don't respond on the first day and I don't respond on the second day, please resend the email. I might have missed it. Now, I think we can now start. Any questions before I start? Any questions, or how are you finding the work so far? Guys, how are you finding the work so far? Hmm? How are you finding the work? Yes, please.
Hi, good morning. Good morning, ma'am. On my side, so far the work I've been able to follow through the textbook and the study guide. So in terms of the real numbers and the exponents, that's what I've been at so far. I'm okay. I'm okay. Thank you so much.
Okay. So for today, thank you, Olisa. For today, we're going to start on chapter 2, right? Because I just want us to cover the part of chapter 2. So can you please study chapter 1? If you have any problems, please send me an email on the particular problem in chapter 1. And then during the discussion sessions, what I'll do is I'll first explain during the discussion class, I'll explain the problem that you're facing in chapter 1. Is that clear, guys? Thank you. Yes. Okay. Please keep on admitting the other students. We'll make it clear later that they should be using their MyLife email address. So on chapter 2, normally when I teach, I prefer you guys having a study guide next to you, as well as your textbook. Do you have your study guide and textbook next to you?
Yes.
Thank you. So on your study guide, please go to page. So it's very important that you look at your study guide every time you study, because then it directs you on what you're going to do, what you need to understand, what you need to study as well. So if we go to page 21 on your study guide, it tells you that for section 2.1 in chapter 2. So let's go for section 2.1. Where's chapter 2? Can you please mute yourself? Thank you. So it says that we have to make sure that we know the definition of a function, how to find the domain in the range of a function, evaluate a function, and representation of a function. Now, let's start with the definition of a function. Can anyone tell me what a function is? Guys? Anyone? Please don't raise your hand because I cannot see from my side when hands are raised. Anyone, can you please give me the definition of a function? Guys, there's no wrong answer. At least try, because if you guys keep quiet, then I'll just keep quiet as well. Can you please try to give me the definition of a function? Hello?
Well, it's really here. I can't think of the exact definition of a function. However, I do know that it has 4 quadrants. which is made up of the x and y coordinates. So we've got the first, which would be the x and y, and then goes on and on. However, as I mentioned, that I do not have the exact definition of a function.
Okay, thank you, Goli. Anyone else? Lebohang, please don't raise your hand, just speak, because guys, if I change the screens, I can't see who's raising their hand.
Okay, I'm sorry about that. A function is a relationship between the x coordinates and the y coordinates in a Cartesian plane.
Okay. So okay, let's have an what's this last definition? Can we please have last definition of a function? Guys, we need to move. And you know you'll be submitting your assignment too, so we need to cover everything in assignment 2.
I think a function is a relationship between a set of inputs and outputs. When you put a one input, you must get one output.
So is it you put one input? So is it a relationship between one input and one output?
I think so. But all I know is that you have to have one output in whatever you insert in.
Okay, thank you very much. So if I summarize the definitions and just to take it back, remember that when you're doing mathematics, you also have to look at it in a point of view of a real world situations, right? So now in mathematics, what happens is we take real life situations and then form them into what's this mathematical equations. Now a function is a relationship between what's this independent variables as well as dependent variables. As one said, that the input, meaning that you can have more than, what's this? You can have more than one input and get one output. For example, let's say you are going to, the relationship between passing the exam as well as the activities that you do, meaning that if you put in studying, if you put in work, what's this, hard work, then the output will be passing. If you put in, I don't know, not studying, that being one of the what's this, one of the independent variable, putting spending time on social media, meaning then the output will do what? Will definitely be that you will not be able to pass. You will not be able to pass the exam. So now the function, as they said, it's a relationship between the dependent variable and the independent variable. Now on page 148, they actually give examples of the relationship between what's this, dependent variables and independent variable. For example, height is a function of age, right? You cannot have, not in most cases, but you cannot have a baby that is 156 tall. Do you understand? So meaning that height is a function of variable. Now temperature is a function of dates. Cost of mailing a package is a function of weight, meaning that the heavier your package, the heavier what? The more costly is the package. So basically a function represents what? A relationship. Now, when one said that a function is a graph in a Cartesian plane, you're actually giving another way of representing a function. Remember, a function can be represented in words. You can describe the function. It can be represented mathematically. It can be represented graphically, and it can be represented in a form of a table as well. So when it comes to exam, I need to warn you, we're not only going to be solving, but you're also going to be encountering questions where you are asked which, because your exam is MCQ, so which choose the following, choose the correct definition of a function in the following options. So if then you don't know what a function is, then you'll be choosing the wrong, what's this? You'll be choosing the wrong answer. Are we all clear there? Guys?
Yes.
Okay. So now, on page 148, so you guys will go through everything, but I'll just touch in the very important parts. On page 149 of your textbook, it gives a definition of a function. One thing you need to know is, in your textbook, make sure you understand those small blue box. Very important. Those are the keywords. So now they're saying a function f is a rule that assigns to each element in x in a set A exactly one element called f of x in a set B. So what they mean is you have a set of x values in A, right? So these are your x values. And then you have a set of y values, right? Meaning that you take an x value here, you substitute into f of x, whatever f of x is, based on the definition of the function that you're given. You substitute into here, and then you get exactly one y value. So one value from here, you get exactly one value. One value from here, exactly one y value. Does that make sense? Guys?
Yes, ma'am.
Thank you. So meaning that if, for example, you have, okay, let's choose a different color. You have this point here. You have a point here, right? And this point takes a value there and comes back, it takes another value there. Then that's not a function. Are we all together?
Yep.
Yes.
Thank you. So then that's the definition of a function. So now they are saying that for a function to be defined, where all these x values, such that you substitute in this f of x and get the answer, which is a y value, then all the set of these x values are called what? Are called the domain of the function. Are we all together?
Yes.
And then the y values for which this function is defined are called the range of the function. Are we all together? Now, in this module, when I say find the domain of this function, our domain will be represented as D, F like this, and our range will be represented as. So this means the domain of F and the range of F. Are we all together?
Yes.
Yep.
Thank you. Now, they are saying that if you take a value of x here, right? Okay, let's choose a different color. Draw. Okay, what's going on now? Thank you. If you take a value of x here, right, and substitute into the function here, whatever you get here is the value of f at x, right? Or sometimes called the image of f and the image of x under f. So these y values will be called what? Will be called the value of f at x or the image of x under f. We are all together.
Yes.
Yes.
So we're still on the same page. Now they say that if you're given y is equals to f of x, for example, right? And then they tell you that the symbol that represents arbitrary numbers in the domain of function f is called the independent variables. So what do they mean? Which ones are the independent variables? Guys, which one are the independent variables?
The
It's
range.
X.
The x exists. The x.
Thank you. The x are the independent variables and y are the dependent variables. Reason being, you take the inputs are your x, and whatever value of y you get depends on what? Depends on x. That's why x are the independent variable and y is the independent variable. Are we all together there?
Yes.
Yes. Yes.
Thank you. So one of the representation of a function is a machine diagram. For example, they say you have y is equals to f of x. Now, I'm not good with drawing, so I'll try to draw that machine. So something like this, where they say you take x, you put it into that particular machine, and then you get the value of y, which in this case is f of x. Do you see that? So whatever f is defined, let's just call it f at this point. So you take the value of x, put it into the machine, and then get the value of y. So then that is called the machine diagram. Are we all together there?
Yep.
Now on page 150.
Yes.
On page 150, if you look at A, right, figure A, it's the one that we were talking about, that if you have A here and you have B there, and these are the x values 1, 2, 3, 4, and these are the y values. So if one value from here only maps to one value in here, exactly one value in there, then that is a function. That's A. Now, the figure 4b shows you that it's not a function if one value here maps into two different values here. Then that's not a function. Sorry. Yes, then that's not a function. Are we all together?
Yes.
But please note that one function here, one value here, can map to one value there, right? Then another value here can map to the same value in y. That is still a function, but it has a different name. Are we all together?
Yes, ma'am.
Okay. Can I have 3 yeses, guys?
Yes,
Just to
we'll
confirm.
Yes.
Thank you.
Another yes from me.
Thank you very much. So now, analyzing a function, let's look at example 5. What am I saying? Example 1. It's analyzing a function. So they're saying we're given f of x is equals to x squared plus 4, right? Remember, I said one of the ways of describing a function is in words. So they want you to express in words how f acts on the input x to produce the output f of x. Can someone explain in words? What did you do to x such that you produce f of x? And you need to know how to explain in words because it's a question that might appear in the exam. So everything we do might appear in the exam. Not everything, but most of the things. Yes. Can someone explain what you did to x so that then you can be able to get f of x?
You would first have to square x and then you add 4 to it to get the f of x result.
Thank you. Are we all together there?
Yes.
Thank you very much. Can I please have 3 yeses?
Yes.
Thank you. So now, what does it mean to evaluate? Because it says evaluate f of 3, f of negative 2, and f of square root of 5. What does it mean to evaluate? Guys, what does it mean to evaluate?
Wouldn't it
try.
mean to get the
Yes.
to get the value of f of x if the variable is substituted with for example, with the 3 as given?
Thank you. So when they say evaluate, meaning that if they give you f of 3, f of negative 2, and f of square root of 5, they're telling you that in f of x, where you see x, put 3. So this will be f of 3 equals to, I see x, I put 3, 4, this will be equals to 13. So then f of -2 is equals to -2 squared plus 4 equals to 8. Then f of square root of 5 equals to the square root of 5 squared plus 4 equals to 9. Are we all together there? If you don't understand how I got anything, why I'm doing it, please raise up your hand. Remember, we are all writing the exam individually. And the exam, just a tip, the exam is different. So your exam, my exam might not be like Oli's exam or Kia's exam. Same questions, but different. Yeah. So that's what I'm saying. If you don't understand, please let me know so that I explain. Are we all together there?
Yep.
Thank you very
Yes,
much.
we are.
Yes.
So now number C, this is one of the questions, find the function. If you notice in your assignments, it's there. So it's very important that you understand it. Find the domain and the range of f, and it will be there in the exam. So you see, I'm even giving you a mark there. It'll be there in the exam. It's always there in the exam. So find the domain and the range of a function. So you're given f of x is equals to x squared plus 4. Is there anyone who has a problem with finding domains and range of a function? Because I also had a problem in my years of studying.
Yes, I have.
Okay, so what do you think a domain in the range is? I want you, by the time we write the exam in December, not in December, but in October, November exams, I want you to be perfect. What is the problem? What do you think is the problem? I'm sure you tried it.
I just
and you're
don't
like,
get why.
Yes?
I just don't get how they get the domain and range. Like, how did they get the numbers if I'm given x squared plus 4 and there's no other number? I don't know how they get the domain and range.
Okay. Anyone else? The others, are you okay with the domain and the range?
I think I'll just like to follow on what the other lady said. I got here a bit late, so I am a bit confused as well as to what the domain and the range is. But if I'm taking it from the few minutes that I just watched when you explained the domain and the range and looking at the textbook with regards to the input and the output, then I would probably assume that the domain is the input. So I would most probably assume that the x squared plus 4 could be considered a domain, and the f of x, which would now be the result from the calculation of the x squared plus 4, I would probably consider that to be the range of it.
Yeah, you're actually right. You're actually right. But then now, how do I write it in mathematics now?
Oh,
Because remember, in
the
our
part I
mathematics,
know.
there'll be numbers. So let's write what you just said. So the domain of this function will be what?
X squared plus 4, or do you say in numbers?
Yes, remember that it will be represented. So a domain, it's a what's this? It's a place or a set of interval at which the function is defined. Right? Meaning that, so okay, listen to this. Especially those who say that they don't understand the domain. Name? This is how I would this is how I got the domains when I was in my years. As he explained that it's the input and the output, right? Now, think about this and look at this function. Is there any x value such that when you substitute here, your calculator will say error?
None, ma'am.
None.
Yes.
Do you agree with her?
Yes.
Anyone? I need 3 yeses. I work with 3 yeses, guys.
Yes.
Okay. So you are saying that for this function,
Ma'am.
Yes.
Isn't the x value supposed to be a real number?
Yes. we are working with real numbers for Math 1510. That's why you're only studying chapter 1 to 7, skipping a chapter between. So we are only working with real numbers. Let's not focus after 7, chapter 7 of the table. Yes.
Okay.
So us here, the square root of a negative number, we don't look at it here. We say it's undefined. Now, as with real number, we all agree. We're saying that there's no value of function if I take it negative million, if I substitute here and I will not get an answer. Isn't it? That's what you're saying. Guys, is that what you're saying?
Yes, ma'am. Whatever number you're gonna substitute for x will give you a defined, like it's gonna be all right.
Defined answer.
Thank you. You see that statement? How is it written? It means that the domain is x element of
Or real
real
number,
numbers.
or minus infinity to positive infinity.
Thank you. Now, if I mentioned in the exam and I say I wanted an interval notation or set notation, you have to write it in that. Or you can write it as negative infinity to positive infinity. So that's the domain. Did you see that? Guys?
Yes.
Are we all
Yes.
okay with the domain now?
Oh, just explain again.
You look at the function and say which value of x, if I put in here, it will, for example, if you say I choose 1, you put 1 in the calculator. I know I say we shouldn't use calculators, but in the calculator, you get an answer and you don't get an error. If there's no value there, then your domain is always negative infinity to positive infinity. Are we all together there? Don't worry. There's more domains and range. You will see the difference. Are we all together there?
Yes.
Yes.
Thank you.
Yes.
I don't understand.
Okay, which part? Which part don't you understand?
What part of negative infinity and
So
infinity? I don't understand it.
So normally when you say negative infinity to positive infinity, you mean any value of x. Do you understand? So you are saying that I'm taking,
Okay.
if I take any value, if nkachiya value ya x, enwale substitute into the function, kitlo thola answer. Uma ngathatha i-value ka-x noma yiphi from negative infinity to positive infinity ngiyifaka ku-function la, ngizothola ini? Ngizothola a value of y. So that's how you will look at your function. So let's continue so that you see other example. Now on example 2, it says, are you okay now? Sorry about that. Are you okay?
Yeah.
Thank you. So now in example 2, it says evaluate again. So we'll just do that very quickly. Our textbook does things step by step. So it means that let's do that as well, because so it says evaluate, meaning as you mentioned, what's this? Before it says you substitute the value. So inside where you see x, here it says where you see x, put what? -2. So that's -2 squared plus -2 minus 5 is equals to 5. And then you can go and do number B, right? Okay, it's f of, so with number B, go and try it, f of 0. And then number C, okay, let's just do it, guys. So f of 0, where you see x, so 3, 0 squared plus 0 minus 5. The answer is -5. And then C is what? F of 4. So meaning that where you see x, you put 4 squared plus 4 minus 5 is equals to 47. The last one, here. The last one is what? F of a half is equals to 3 times 1/2 squared plus 1 over 2. Sorry, the color is changing there. Minus 5 is equals to, they say 15 over 4, negative 15 over 4. Are we all together there?
Yes.
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 Ma'am.
Are we all okay with, or maybe I should choose a red color. Are we all okay with the same color? Is it clear that side?
Yes, ma'am.
It's
It's good.
Thank you.
Yeah.
So now, in example 3, they're looking at a piecewise function. Can anyone tell me what a piecewise function is or think what a piecewise function is? Guys, anyone? Can anyone tell me what a piecewise function is? Or
What, ma'am?
try? Yes, a piecewise function. It's in your assignment, guys.
Piecewise function.
What do you think piecewise mean?
Like part of
I don't
it.
know.
Maybe part of it.
Part of it?
Yeah,
Another
like
answer?
a segmented form of it, like it's in segments of, maybe using two different, or I don't know, using two different values to get a value, or two different forms, or two different formulas.
Okay. So that's good. So now, okay, let me give an example of a piecewise function, right? Remember we said a function is defining a relationship between something, right? So meaning that, for example, someone who knows Joburg and Cape Town, right? So the temperature, let's look at the temperature. The temperature that you will experience in Cape Town, CT, and then in Joburg. Here, it's different from there, isn't it? Because here, it's a different area compared to this one here. Does it make sense?
Yes.
Yeah.
So it's not like one function where you say temperature in Joburg is 30 what degrees. Do you understand? But if you're saying in what's this? If you're looking at different cities and you want to represent the temperatures, you can also represent it as in a piecewise function and say, okay, fine, temperature in Cape Town, because it's a different region, it's this one. Temperature in Joburg, it's this one. Make sense?
Yes.
Thank you. Now, let's look at the example that they gave you. Now, this is a nice example. It's very important that you are able to take from words to function and from function to words. Now, here they say, okay, fine, you have a cell phone plan, meaning that you have a contract. Yeah? Now, this contract, it's $39 a month. Let's say it's 39 Rand a month. Are we all together? Now, the
Yes,
contract
ma'am.
comes with 2 gigabytes of free data. Ne? And then charges 15 per gigabyte for any additional data used. Do you hear that? So they're saying that you have a contract such that you're going to pay 39 Rand and it comes with 2 gig. And if you use more than 2 gig, then the what? Then you have to pay 15 Rand for the extra gig. So how do we represent that in a form of a function? Because we in that example we move from function to word. Now we are moving from word to function. How do you represent that? Guys, can anyone try? Hello? Are you guys still there?
Isn't it going to be f of x equals to
Yes, f of x equals to
30? You said how much per 2 gigabytes. The
It's
contract.
39 rand. So that contracts, it's 39 rand, and then it comes with 2 gig.
Okay, and then equals to 39
Plus to 39
plus X.
plus X.
Yes.
Can anyone try again? Fast, guys. I need 3 solutions. Thank you for trying. Can another person try?
Wouldn't it be the f of x would be equal to 39, which will be the 39 rand for the 2 gigs plus
Yes.
15, which would amount to, should you use more than the 2 gigs, then you get to plus 15 of the value of x.
Are you saying this?
Oh no, not that.
That's correct, though.
Not. Is it correct?
Yes.
Okay. Now they say the monthly, listen to this. The monthly charges are a function of the number of gigs of data used. So a function of the number of gigs of data used. So what are they saying? The monthly charges are a function of the number of gigabytes of data used.
Oh, now I would understand why that would be the correct equation, because I carry x would now be in terms of the 39 is already for the 2 gigs, and then x would now be, in case it's a 2 gig or 3 gig, then you're gonna have to multiply it by the 15.
Oh, wait, hold it there. So you're saying let x is what?
Let's say let x be another 2 gigs.
Okay, not another 2 gigs. Remember, you can't say me, I'll use 2 gigs. When you start calling there and you're calling for Valentine, you use 5 gigs. So let x be what? Let's make it general.
It's a number of gigs. It's a number of additional gigs, yes.
Thank you. Number of gigs. Okay, they call it giga. What's the abbreviation?
GB.
Are we all together there?
Yes.
Yeah.
Are we all together? Now, so let x be, guys, please mute. So now it says let x equals to the number of gig. Are we all together there, right?
Yes.
Now, what are they saying? The monthly charges are a function of, so remember we said y is equals to f of x. Then we are saying y is a function of what? Of x. So what are we looking for here? When they say the monthly charges are a function of the number of gigabytes of data, what are we looking for? What is the output here? Guys?
Wouldn't it be the amount that it would cost for the entire sum of data used?
Thank you. So then let's call it C. In the textbook, they call it C. We can call it M. Let's call it the charge. So the charge will be a function of what? Of gigabytes. Are we all together there?
Yes.
Yes.
Monthly charges. Are we all together? So what are we looking for here? What are we looking for? We're looking for the monthly charges, isn't it?
Yes.
So now the monthly charges is equals to what? Tell me. What is the statement? They say you paid 39 rand when what happens?
So if I may ask, when you say monthly charges, do you exclude the 2 gigs, like the 39 rand?
No, you don't exclude it. But the statement said a contract costs 39 rand a month, right? The plan includes 2 gig, meaning that the plan includes 2 gig. So how much are you going to pay if you only use 2 gig?
39.
Thank you. So if you use more than 2 gig,
you pay per additional gig, which is 15 rands.
So it means that all these functions you are calling here are wrong because now you are giving me 2 statements.
You don't even have time
See
to
that?
do that, so you need to say.
Guys, please
mute.
Do you see that? You gave me 2 statements. So here it's only 1 statement. This is wrong. Because you are saying that you're going to pay what? You're going to pay 39 if you use 2 gigs, and you're going to pay more than that if you use more than 2 gigs, isn't it?
Extra gigs.
Yes.
Thank you. So how do we write that in a, okay, so let's come here. That's where the step function comes in. So you're saying I'm going to pay 39 if I use 2 gigs. Ne?
So, yes.
What is gigs? Gigs is X, right?
Yes.
If I use less than or equals to 2 gig, or
39.
you can never use, guys, you can never use negative 2 gigs. Does it make sense? So meaning that it's either you don't use a gig or you use gig 0.5 megabytes or you use 500 megabytes or whatever. As long as you fall under this interval, you're going to pay 39 gig. I mean 39 rand. Does it make sense?
Yes.
Yes.
Now, if I use more than 2 gig, how are you going to write the interval? So this is an if here. If what? Let's write if I use more than 2 gig, how are you going to write it?
Is the monthly charge?
Thank you. Do you see that? You're saying if I use gigs that are more than 2, isn't that you defined it as X? If I use gigs that are more than 2, then how much am I paying?
15 rand per gig.
So what will be the function here? Let's work on the.
So you're gonna pay 39 for the 2 gig. If you use more, they said if there's gonna be an additional of 15 gig. So we don't know how many gig you use extra. So say if you get 4, so you're gonna say times 4 minus 2 because the 2 is already for free.
Did you hear that? Guys?
Yes.
Can she repeat?
Okay, she's saying that. Isn't that we are saying more? We are all together on more, right? More than 2 gig.
Yes.
So if you are using more than 2 gig, you're going to pay 39 rand plus 15 rand times the number of gigs. Right? Are we making senses?
Yes.
Yes.
But if in a month you used 4 gigs, are you going to pay for the whole 4 gigs?
No.
No.
You are going to pay for how many gigs?
For 2 only.
Thank you, for 2 only. So it means that if you use 4 here, the X is 4, you are going to subtract the 2 that you getting for free. Makes sense, isn't it?
Yes.
Yes.
So meaning that if you use 6 gigs, you are going to pay for 4 gigs. Let's see, 39 plus 15, how many gigs? 6 minus the 2 free, 39 plus 15 times the 4 gig. So stop calling too much because you're going to pay more. So that's why they got the equation plus 15x minus 2. Do you see the how you draw the function, guys? The step function.
Yes.
So it's important that you are able to take it from words, put it into function. I know in the assignment we have function, so you never know. In the exam you might have words, and then you have to do what we just did here. Are we all together there? I didn't lose anyone. I need 3 yeses.
Yes, ma'am.
Yes.
Yes, ma'am.
So this is the answer, and then they say if your gigabytes are between 2 and 0 and 2, 39 rand plus 15, I mean x minus 2. If you use more than x greater than c, greater than 2. Saying evaluate 0.5. You see that I was answering a question that was not asked, but it was very important because you need to know it. So they're asking you, how much is this person going to pay if they use 0.5 gigabytes? So let's see, the cost of 0.5 gigabytes will just be 39 rand. Do we all agree? You don't even have to calculate it because it's here.
Yes, ma'am.
Thank you. Now, if this person uses 2 gigs, still the cost will be 39 rand. We don't have to calculate it because we know it's 2. It's still here. Do you see that?
Yes.
Now, the cost of 4 gig here, 4 gig now is x is not between 0 and 2. It's here, greater than 2. So then we go and say 39 plus 15, 4 minus 2. Then we get the answer, which is 69. Are we all together?
Yes.
Thank you. Now there's a statement that says from examples 2 and 3, we see that the values of a function can change from one point to another, right? Now, since they can change from one point to another, then you can call the net change in the value of function. You can call it the net change in the value of function. Now, what is the net change in the value of function? The net change in the value of function of f as the input changes from point A to point B, right? Meaning that the function, you saw that from here to here, the function changes, isn't it? Now, if you're asked to find the net change, it means that the function f is changing from A to point B, where A is less or equals to B. And therefore, the net change is given by f of B minus f of A. Are we all together then?
Yes.
Thank you. Another yes, another yes.
Yes.
Yes, ma'am.
Thank you very much. So I need to come here. Now I'm going to do one example and you do the other one. And then if you don't get it, come back to me. So then f of x is equals to x squared. I hope I'm recording this video. Otherwise, I'll be in trouble. Yes, I think it's recording. Is it recording, guys?
Yes, I see it.
Yes, it's recording.
Yes, it's recording.
Thank you. So now f of x is equals to, and they say find the net function in the value of f between the given points. So a, they say from what? From 1 to 2 to 3, sorry. So meaning that they want you to just find f of 3 minus f of 1. You see, if you don't know the terms, you just get it wrong because they just want you to substitute and subtract. So that where you see x, you put 3, so that's squared, minus where you see x, you put that. So that is what? That is 8. Are we all together then?
Yes.
Yeah.
Thank you.
Yes.
Hey, they like this evaluating. Eh? So now they say evaluate a function. So that is page 155. They want you to evaluate the following functions, right? So let's choose only a few, and then I want you to go and do the rest. Guys, it's nice that when we do the section, you go back and do all of the examples, and then you come back if you have questions, right?
Yes.
Thank you. So now let's do the last evaluation. You have f of x is equals to 2x squared plus 3x minus 1. And they want you to find f of a. In this case, f of a is what? F of a. So meaning that where you see x, you put a. So this will be 2a squared plus 3a. You see I put in brackets so that you don't make mistakes when it comes to sign. So this is 2a squared plus 3a minus 1.
Yes.
Are we all together there?
Yes.
Yes,
Now,
ma'am.
f of negative a, so this is equals to 2 negative a squared plus 3 negative a minus 1. So what did they get there? They got 2a squared minus 3a minus 1. If you didn't get it, please make sure you come back to me and say, I don't get it. Are we all together there?
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now skip to the domain and range, right? So you'll go through all you'll go through the remaining question of in the example. We can skip for now. We can skip example 6. Let's go to the domain of a function. Domain of a function. Okay, there's something I didn't do previously. We did the domain, but we didn't do the range. I don't remember doing the range. Did we do the range on the previous
No.
example?
No.
Thank you.
No, ma'am.
No.
Thank you.
No, we did
So
not.
let's go back to the previous example. We said f of x is equals to x squared plus 4, right? We said the domain of this will be x element of real number or infinity. Now let's look at the range. In this case, let's call the range R of f. So this will be equals to what? Can someone try? Can someone try? So you don't say
The
x is an
function of
element
x is greater than or equal to 4.
You're saying what?
Greater than or equal to 4, the range.
So you're saying y is greater than or equals to 4?
Yes, ma'am.
Okay.
I just write a function of x is greater than or equal to 4.
Yes, let's just call it y. They like calling it y equals to f of x or g of x. Is there someone who doesn't understand how they got that? Guys, should I continue or explain?
Can continue.
Explain.
Yeah, explain.
I will explain more further in future when we do functions, but for now it's okay. Let's go back. We said that there's no value of x that we substitute inside and get a negative. What's this? Sorry, what am I saying? There are no values of x such that when we substitute in this function here, they'll give us an error, right?
Yes, which is the domain.
Thank you. Now, if you substitute -1, what do you get here? If you substitute -1, what are you going to get? Yeah.
5.
I think you
Then
get
5.
5. You'll get 5, I think.
Yes.
We get 5.
5.
If I substitute negative,
Let's
mute, guys. If you substitute a negative number, what are you going to get? Can someone say something about a negative number? What's going to happen with the negative number?
It's going to become a
Positive number.
It's gonna be positive.
So am I going to get any positive y values?
Yes.
I mean, any negative y values?
No.
No.
Oh, so you're telling me that I'm not going to get any negative y values?
No, you will if the x value is greater than 4.
You won't get the
I'd
negative
say
values
no.
You won't get
Someone is saying,
because everything squared,
Always get
even if it's
positive.
negative, it won't give you a negative answer.
thank you. Did you hear that?
Wait, yes.
Did you hear that? So whatever value that you're going to substitute in there, it's never going to be negative. You can take -million and square it. It will always be what? It will be always be positive, right? So meaning that you take that statement and say, whatever square value, whatever value of x I put here and I square it, it will be greater or equals to 0.
Okay.
Do you see that?
Yes.
Meaning that, how can we move from here? Remember what we said last time. How can I move from x squared to x squared plus 4? How can I move from x squared here to x squared plus 4? What can I do? Guys? Guys?
I think we don't understand the question.
Yes,
The
I'm also
question
confused
is,
by the question.
remember I asked you to describe this function in words. Someone did describe it, right?
Yes.
Now, I have x squared.
Yes.
And I want to move from x squared and form an x squared plus 4. What am I supposed to do to x squared?
Shouldn't you add 4 to it?
4 to
So you
the,
add by 4.
yes, 4 units
So
up.
let me add by 4 at x squared. So x squared plus 4 greater or equals to, what does math say? When you do what you do on the left, you also do on the
Right.
Right.
Thank you. So you add by 4.
Yes.
So this looks like what? Y. So therefore y is greater or equals to
4.
Okay.
Are we all together there?
Yes.
Yes, ma'am.
Yes.
Thank you. So for a parabola, I'm going to come and teach you a parabola. But for a parabola, right, a function is always greater or equals to than this sign. If it's -4, it's -4, it'll be less or equals to. If it's depending on the sign here, we'll come back to that later on. But as long as you got this, then it's fine. Are we all together on how they got greater or equals to 4?
Where is this 4 coming from?
Yeah?
Where is the 4 coming from on the other side?
Okay. The 4 comes from what you have learned in grade when you started numeracy. When they say what you do on the left, you do on the right. We say that we have f of x is equals to x squared plus 4, isn't it? We say that in the domain, if you take any value of x and substitute into this function, the function will be defined. So therefore, the domain is x element of raw number. Now the range. We say if we take positive values and negative values, if we substitute in this function, they will never be negative. Why? Because if you take a square of something, a square of the value of x, whether it's negative or positive, it will always be greater or equals to 0.
That's right.
Right?
Yeah.
Now we're saying we have this function which is y is equals to f of x, right? But look at this. We have x squared here. We want to change here so that we have plus 4x. So what we can do, it's allowed. We can say x squared plus 4 to make it look like this, right? But remember, in math, what you do on the left, you also have to do on the right. You add this plus 4 as well. So that when you take it this side, it subtracts this 4 and takes you back here. So therefore, this looks like a y. So that's why we put y greater or equals to 0 plus 4. That's 4. Are we all together there? Yes, no?
Yes, ma'am.
Yes.
Yes,
ma'am.
Now, let's try this one. F of x is equals to 1 over x minus 4. Give me the domain. They want the domain here. Give me the domain.
X can't be 4.
Why?
Because it's where it's undefined.
Did you hear that, guys?
Yes, ma'am.
Yes.
Do you see how we look at the domain, isn't it now? The person who said they have a problem, are we okay now?
Yes, I'm fine.
Thank you. So meaning that x cannot be 4. Because if I put 4 here, it will be 1 over 4 minus 4, 1 over 0. What is 1 over 0? Undefined.
It's undefined.
Do you see how we see the domain? Guys?
Yes.
Yes, yes.
Okay, thank you. So you are saying x should not be equals to 4, right? So let's say the domain is x should not be equals to 4. Now, someone might say, okay, guys, this is not what I want you to do, ne? This is what I want you to say. Listen to this. If you have 1 divided by something, ne? You're going to say the domain should, that divide by this something should not be equals to 4. I mean, sorry, should not be equals to 0. Or all together.
Okay.
Yes.
So you're going to say this something over here should not be equals to 0. So what is that something? That something is x minus 4 should not be equals to 0. When you simplify it, x is not equals to
4. It can't be 4.
Do you see how I simplified it? I took 4 to the other side. Are we all together there? I know it was easy to say x minus 4, but this is what I want you to say. You're saying my denominator, whatever is in my denominator, should not be equals to what? Should not be equals to 4. Because sometimes you'll have an equation like this, x squared plus 3x plus 1. So you can't just look and say, you see that you can't just look and tell me x should not be equals to what?
Yes.
So instead you'll say this whole thing here should not be equals to 0, and then you factorize and start solving. We'll come to that later on. Are we all together? We are sorted then, eh?
Yes, ma'am.
Thank you.
Yes,
Now
ma'am.
we have f of x is equals to, I'm not passing here because this one, if I don't put this one in the exam, this is like what? This is like your name. This is like part of your blood, you know, like part of your kidney. It always comes with the body, you see. So in the exam, this is going to be there. Not exactly like this, but yeah, most definitely going to be there. So I'm giving you a mark there. 2 marks, 3 marks, you get it. Now, can someone tell me what is the domain of this? What is the domain of that? You see here, I'm not going to leave until you tell me. Otherwise, we keep quiet, I keep quiet, and then when time hits, and then we switch off, and then we say goodbye. It will be a nice silent moment.
I think x is not supposed to be a negative number.
Why? Why? Because?
I don't know if maybe we need to convert it to an exponent. However, it would still give you a negative number, and we can't be dealing with a negative function.
Yes. Remember that what you did in grade 10? When you put a square root of a negative number like this, your calculator was saying undefined.
Yes.
Do you remember, guys?
Yes, ma'am.
Insert. Yes. Do you see how you're finding the domain now? Are you getting the, you know, that thing of finding the domain? Guys, are you getting it? How
Are busy building.
You say?
The puzzles are busy building.
Yes. So are we getting it? Are we trying now? For those who said they don't understand.
Yes, we are getting it.
Yes. So you are saying, is there a value? Is there a value such that if I put in here, it will make, we are not allowed to use calculator, but based on your knowledge, is there a value such that, why am I pointing with my finger? Is there a value such that if I put it here, the value of x, if I put it here, will it be the function in the calculator, will it say undefined? And yes, all unless x values will be what? Negative x values will be what? Will be undefined.
Was an error.
Thank you. Will cause an error. Yes. Meaning that f of x
can't be smaller than 0.
Thank you. Meaning that whatever is in that square root, in this case is our x, cannot be smaller than 0. But can be 0, isn't it, guys? It can be 0, right?
Yes, yes.
Because if I put there 0, if I put square root of 0 is what? It's 0. So this is part of your domain. Meaning that if you're going to put it in interval notation, x will be from what? Can it help me?
X will be from 0 to infinity.
The brackets. Curly brackets.
Yes.
Square
Brackets.
brackets.
Square bracket then on 0 and parentheses on infinity.
Parentheses like this?
No, like the curly one.
Thank you. Okay, guys, my handwriting is bad. Let's assume curly is like this. Yeah, the C that faces that side. Are we all together there?
Yes.
Yes.
Okay. Can I please have interval notation of this one? So this one is set notation, eh? So your set notation is like this. It has these what brackets. Then x is an element of real numbers. They like writing x element of the real numbers such as x is not great equals to 4. So this will be your set notation. Remember when you represent sets in your assignment, you use something like this. Assignment 1, those brackets. So this is a set notation. This is an interval notation. So there are like 3 notations. There's this notation, and there's the set notation.
The set notation.
Yes, can I please have the interval notation? X is not equals to 4. How are we going to write the interval notation?
X can be include 4. 4 can be
Yeah, so
included.
how would it be with some brackets? I want to hear, when you're talking about interval, I want you to hear brackets, brackets, brackets. If you don't talk about brackets, then you're not talking about interval. So let's talk about brackets.
It's a curvy bracket, then a 4. And to positive infinity with the square bracket.
Why a square bracket?
No, a curvy bracket. It can be.
Thank you. You remember, negative infinity, positive infinity means any number, right? Yes. So you can never include what you don't know. So if you have negative infinity, it will always be that curly bracket. Yeah, like that bracket. Guys, this is answer number 1. Can I please have answer number 2? Or we agree with answer number 1? Majority counts. Majority wins. If all of you say answer number 1, and me, I don't think it's answer number 1, and then it means that we're going to go with answer number 1. Isn't that it's voting? We are voting. Guys? Hello? Are we agreeing with answer number 1? Guys, can we finish this section, please?
Ma'am?
Yes.
It's a curve brackets. Negative infinity. 4. A curve bracket. Union. A curve bracket. 4 to infinity.
Positive infinity.
Positive infinity. Then a curve bracket.
Can you please repeat after union? Union?
4.
It's a curve bracket 4. To positive infinity.
Are we all okay on how she got it?
Yeah, I agree with that one.
No, I don't understand.
You don't understand? Let me take you to number line. Do you remember a number line?
Yes.
Straight line like this? Okay, it's not like this, but it's a straight line. Mine is, I don't know what it's called, right? And you have zeros here, right? You have a 0 and you have positive this side on your right and you have negative on your left, right? Now, they are saying x should not be equals to 4. So meaning 4 is not included, isn't it? Right?
Yes.
All together there.
Yes.
Meaning that our function is defined for all these values, x values, blah, 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 blah. And then when it comes to 4, the function is no longer defined, isn't it?
Yes. Yes.
And then it jumps 4, and then it says, me, I'm defined now. Up to positive infinity, isn't it?
Yes.
Yes.
Now, by looking at this, these numbers, this side, can be represented by what?
By negative infinity.
By negative infinity, isn't it? These numbers from this side can be represented by what?
Negative.
Negative infinity.
Positive infinity. Are we all together, right?
Yes.
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 Hold it there. Hold it there. Remember, it's a puzzle. Hold it there. Now we are saying that our function is defined from negative infinity. That's what we're saying. We are saying our function is defined from negative infinity, negative infinity, negative infinity, negative infinity. Remember, negative infinity, né? We write it like this, isn't it?
Yes.
Yes.
Up to what? Where do I end?
Up
Where
to
do I
4.
end? Up to 4.
to
Thank you. Up to 4. But is 4 included?
No, it's not.
It's
No,
included.
Thank you, because you said not equals to 4. 4 is not included. If something is not included, you put this bracket. If it's included, you put this bracket. Are we all together?
Yes,
Yes.
ma'am.
So you are saying, okay, now let's go to the other, let's jump 4. We come here. Where does it start? At the red part, where does it start? It starts at 4, right?
Up to 4.
But it doesn't include 4.
Oh, yes.
And then where does it go?
To positive infinity.
Positive infinity. And we know a union means or. And intersection means and. So in simple English, you are saying our function is defined here. Here. Right?
Mm-hmm.
Or here. Did you see what I just did there?
Yes.
You're saying our function is defined here or here. That's why we're putting this. Are we all together now?
Yes.
Yes, ma'am.
Yes.
Good.
Yes.
Now we can move on. We see we are getting there. Okay. Now, A, f of x is equals to, I want all the forms of the notations, x squared minus x. Domain. Can someone help me? Domain.
Wouldn't it be x squared minus x should not be equal to 0?
La. Thank you very much. You see why I said you should write ls, because here it's a denominator, and denominator cannot be 0. Therefore, it's x squared minus x should not be equals to 0, because because this is the whole denominator. If this is 0, then it's undefined. Do I leave it like that?
I would say under the circumstances, yes, since we do not have any value for x.
No, we solve it. We don't leave it like that. So remember, here you can factorize. Can someone help me factorize?
It's going to be x open bracket x minus 1.
Minus 1.
Do you see that?
Mm-hmm.
So now, where can this expression be 0? When can this expression be 0? If, let's put it here. When can that expression be 0? When can x x minus 1 becomes 0? When?
If x is equals to 1. Okay.
Only.
And x equals to 0.
And x equals to 0. Are we all together there? Because if I put 0 here, 0 multiplied by this thing, it will be 0. But if I put, yes, so if I put 0 there, so I have 0, 0 minus 1, this will be 0. If I say, okay, fine, 1, so x is 1 here, and then 1 minus 1, this will also be 0. So meaning that x should not be equal, because we're saying we don't want 0. Isn't that here they're giving us 0, these values, right?
Yes.
Meaning that we don't want them. We don't want them, because if we use them, they'll give us 0. Meaning that x should not be equals to what? 1.
To 0 and 1.
Do you see that? Or x should not be equals to 0.
0.
Are we all together there?
Yes. Yes.
Thank you. Now, give me interval notation. Give me interval notation. Quick.
Curly bracket negative infinity to 1 to 0 to 0. Don't include the 0. Then union. No, wait, it's actually to 1.
But what is your word?
To 1.
Yes. Not included. Yeah.
You're right, no 0.
Okay, let's finish this one. Guys, are you still having a problem with interval notation? Should I explain it with the number line again for the last time?
Yes.
Yeah.
I think it's
okay. Look at the number line. Ne? You see the number line? There's a 0 here, right? Let's put a 0 there. And they say 1 here, right? 1 there. Ne?
Yes.
Now they say not. It means you are canceling these two. This one and that one. Do you see that?
Yes.
So meaning that your function will be defined from here to up to here. Skip 0, defined from here to here. Skip 1, defined from here to here. Do you see that? So can someone tell me based on the number line? So it will be from?
Negative infinity to 0, both not
Yes.
included. And
Yes.
Union
0.
0 to 1.
Thank you.
And then union 1 not included to infinity not included.
Do you see that?
Yes.
Thank you. Let's move. So we have g of x equals to square root of 9 minus x squared. Let's find the domain. From what we have learned, we said what? Simple English before we even do the maths. We said what from what we have learned?
The number under square root can be smaller than 0.
Okay, thank you. So can be smaller than 0, but can be 0.
Yes, exactly.
So let's write it mathematically.
9 minus x squared is greater than or equal to 0.
Thank you. 9 minus x squared is greater or equals to 0. Are we together there?
Yeah, boo.
Okay, help me.
Yeah.
Please help me.
9.
So we subtract 9 on both sides.
Then we factorize.
Thank you. You should be very careful. You should be very careful. You factorize. Please help me factorize.
Yes.
It's going to be open bracket x minus 3. X minus 3. Oh, minus, wait.
You'll confuse us.
X minus 3.
Minus.
Can someone, there's something I'm seeing, and if we continue saying x minus 3, it will we are shooting ourselves in the foot. And what is that?
It's 3 minus x.
Minus x.
Yes. So how can we change the minus x? Wait.
We can divide by minus 1.
Both sides, isn't it?
Yes.
Or multiply by -1. So if we divide by -1, so let's write it on this side. So we have 9 minus x squared greater or equals to 0. Divide by -1. We just want to change the sign. Ne? Are we all together there? Right?
Yeah.
So then this becomes what? This part becomes what?
Minus 9.
Thank you. X squared minus 9. Then? Guys, then?
It's going to be equal to 0.
Smaller or equal to 0.
Thank you. Less or equals to 0 because the sign changes when you divide by -1. So x squared minus 9 smaller or equals to 0. Are we all okay now?
Yes.
Let's factorize then.
It's going to be x minus 3 and x plus 3.
Okay. Then? Then?
X equals to 3, x equals to minus 3.
Guys? What's going on there?
X is smaller or equal to -3.
2, 3.
Or x is smaller or equal to 3.
Right or wrong, guys? Guys, I'm taking you back to inequalities. Right or wrong?
Correct.
The first one equals to 3. The second one equals to -3.
I think x is greater than or equal to -3, and the other one is 3 is.
Guys, why is it?
The top one, I think the side. You must look the other way on the top one, I think.
No.
Other way.
Yes, x is greater than or equal to -3. Like that.
Why are there so many answers? It means, are you guys sure about this? Or should I explain? Or should I come with a way of explaining?
I think.
I think the bottom
Are you okay?
Ma'am?
Yes.
Shouldn't we try to find critical values instead, and then we go and check on the number line?
Thank you. Thank you very much. Guys, why do you forget your grade back work? Grade 10, 11, 12. What are the critical values? Remember you said x is equals to -3. Thank you. So your critical values in this case is -3 and +3.
And 3.
Then you go and draw your number line. If you just look at it, if you can look at it and say, x is what, then it's fine. But if you can't, then follow this method. Then you draw what? A number line, isn't it?
Yes.
And then Where do I put -3? Then you put your critical values. Where's -3? Where's +3?
-3 is on the left.
Thank you. Then what do I do?
You check where it satisfies the smaller than.
So where did you check?
From -3 to 3, then in between.
So how do you check?
You substitute further values.
Okay, substitute further values.
Yes, gather values. So like with negative, if you're checking on whether x should be less than -3, then you'll substitute gather values that are less than -3. On the left, yeah, -3. So you'd put 9 minus x, or 9 minus open brackets minus 4 squared, and then you check if it's greater or equals to 0.
So I give you 5 seconds. Do that while I'm counting. 1. And I want you to give me the whole answer. 1, 2, 3, 4, 5. Did you get the answer?
No.
Hmm? Did you get the answer?
Yes, it's -7.
So you didn't give me the answer for the whole thing. You're only checking for 1. I wanted the whole answer. For the whole inequality. Okay, guys, listen to this, ne? So I have a problem.
I have the answer.
Yes.
The correct values to x are the values that are in between -3 and 3.
Yes.
What did you do? What did you do?
I checked for the values that are before -3, that are less than -3, and the answer was less than 0. And then I checked in the values that are between -3 and 3, and the answer was greater than 0. And then I checked for the other one, and it was also less than 0. So that means the correct values are in between -3 and 3.
How long did it take you?
You just substitute 2 values, but okay, 1 value, because like since this is a parabola, this function is a parabola, you know that when you check for values, the ones that are outside of the interline, if the values are outside of the graph, then if you know that those ones don't fall in the interval, inside the graph, or the answers inside the graph fall inside the interval.
Okay.
Or the reverse of that.
Okay. Who understood from what has been said so far? Guys?
I'm lost.
I understood, but I do it in a different way. I draw the parabola, then shade in between.
Guys, I want you to do it in 5 seconds. It's a parabola. I want you to do it in 5 seconds. Okay, look at this. So this is how I'm showing you what I used to do when I used to, it would give me a problem, right? You see it's a parabola, right? If you're given a parabola like this, unless you're given x plus 3 over x plus 2 and they say greater than, less than, then you can do all those substitution and whatsoever, right? But if it's a parabola, you get your critical values, right? Are we all together there?
Yes.
Okay. You get your critical values and you substitute your critical values in the number line, right? After that, you go and say plus, minus, plus, always. Plus, minus, plus. Are we all together?
Yes.
And then you go and check your sign. What does your sign say?
Smaller than.
Smaller than is represented by what? Sign. Sign-wise.
Negative.
Then you put your x where you see a negative. Where is the n negative?
In between.
In between. Put your x here. Right? Now. What? I had a Did you see what just happened?
Yes.
So we went to this. Isn't that we're here? Ne? The first step, you will say plus. You say plus, minus plus, always, if it's a parabola, isn't it?
Yes.
And then you go to your sign. What does your sign say here? Less than, isn't it?
Than, and it's negative.
Yes.
There we go. And then you go put your x where it's less than. So it means you need to put it between -3 and 3, right?
And 3. So
Now, this is a shark, right? It has teeth. Between a big fish, if you were a shark, between a big fish and a small fish, which one were you going to eat? Between a big body of food and a small body of food, like it's very tiny, which one are you going to eat?
a big one.
A bigger one.
A big one. So the number x, if a number x and 3, which one is big?
It's 3.
3.
It's 3. Then the shark will eat 3. Between -3 and x, which one is big?
It's 3.
X.
It's x.
There we go. The shark will eat what? Will eat x. Now, because there's an equal sign here, the shark will weigh its equal sign. Therefore, you drop it. Therefore, this becomes x.
I did that.
Do you see that?
Yes.
Yes.
Yes, ma'am.
Thank you. It's now in the mind, isn't it?
Yeah,
Yes.
thank you. That's very interesting.
Good. Now, let's assume, okay, so this is our solution, isn't it? Interval notation. Anyone, interval notation very quickly, please. The function is only defined here.
Box brackets on, then -3, then 3, then box bracket again.
Thank you. Now, are we all okay with this one, right? On how to find it now.
Yes.
So this is less or equals to, ne? I want you to show you the last one. So let's say this is x minus 3, x plus 3, and the sign is greater or equals to, ne? Then we go, isn't that we said critical values? It's 3, I mean -3 and 3.
And 3.
And then you go and draw your number line. And then you put -3 here and 3. And then you say what?
Plus,
Guys?
minus.
Thank you. You say plus, minus, plus. So you go to your sign. Your sign is what?
Greater than or equal to.
So where will x be?
On the positive
On the
side.
plus.
Thank you. You put an x here. You put an x there. Right? We
Yes,
said
ma'am.
the shark eats what?
The
The
bigger one.
bigger.
The bigger number, isn't it? Between x,
Yeah.
between this value of x here, if you choose a value of x less than 3, maybe let's say -4. Between x and 3, which one is a bigger number?
-3.
-3, because the shark comes with an equal sign, it will eat that. Between 3 and x, which one is a big number?
X.
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 So then this will be x less or equals to 3 or x greater or equals to 3. That's how you solve it. Are we all together then?
Yes.
If the sign was greater or equals to.
Interval.
Okay, interval notation. Please go and do it and then send me an email. And I'll tell you if it's wrong or right. Okay, why is my pen doing this? So h of t is equals to, we're running out of time. I think we have run out of time. So square root of t plus 1. Please help me. Domain.
T plus 1 is smaller or equal to 0.
Nope.
Greater. Smaller.
No,
Greater.
the denominator cannot be 0. There's no
Greater
equal.
or equal to 0.
There's no
Okay.
equal to on the denominator.
Wait. Let him write it. So it's what? It's greater or equals to 0, ne? That's what you're saying, isn't it?
Yes.
But look at this. If you substitute the square root of 0, you get 0, isn't it? If you put t over 0, what is it?
It's undefined.
So meaning you're not supposed to put there?
0. It's not supposed
There we
to
go. Did you see that, guys? Did you see that?
Yes, ma'am.
All along we were saying that t should be greater or equals to 0. But because now t has become, this thing has become the denominator and we know it can't be 0, we remove the 0 part.
Yes, yes.
So therefore t should be greater than what?
0. And -1.
Are we all together?
Yes, ma'am.
Thank you.
Yes, ma'am.
You will go and write the interval notation, which is -1 to positive infinity. So they say on page 154, there are 4 ways of representing a function. Verbally, you need to know that. That it means you need to describe as we described in the first example. Algebraically, as we are doing here, h of x is equals to t over square root of t plus 1 by graphs, meaning you can draw it, or numerically by using a table of values. Are we all together there?
Yes, ma'am.
So in the exercises, guys, you can do the odd ones because they have answers at the back. If you still have a problem, yes?
If I attempt the even one and I get stuck, can I email you?
Yeah, but you can't email me the whole even.
No, like 1 or 2.
No problem, no problem, no problem. Yes. So now graphs of function. Remember we were having equations, isn't it? We described it numerically. We describe the function numerically. I think we'll end at 1. I just need to finish this section with you guys. So we described it numerically. I mean verbally. We did the whole equation h of x equals to what. Now we are doing it graphically. So you'll go and read there on section 2.2 graph of function. And then it says the graph of a function, if f is a function with a domain, we know what a domain is, then the graph of f is the set of ordered pairs. As someone mentioned that in a Cartesian, you see when you talk about in a Cartesian plane, you put pairs of points, which is x and y, then you call that a graph of a function. Plotted, so they're saying that if f is a function with a domain A, then the graph of f is a set ordered pairs and then plotted in the Cartesian plane. In other words, the graph of f is a set of all points x and y such that f of x, such that you can be able to draw the graph, basically. Now, you need to be able to identify, if you're given y is equals to mx plus c, you need to be able to identify whether it's a linear graph, a parabola, but that one we will do it later, a linear graph, a parabola, but y is equals to a number b. It's called a constant function. Are we all together there?
Yes.
So they're saying that y is equals to m. How do they write it here? I'm sorry. Mx plus b. So y is equals to mx plus b. They call it a straight line. Y is equals to a constant b, where b is 1, 2, -5, and whatsoever. That's a constant function. This is a linear function. And then they say y is equals to x to the power of n. That's a power function. And y is equals to x to the power of n over 1 over n. That's a root function. Now, they're saying that, okay, fine, we can draw a graph using by plotting points. Do we all remember that, or should I explain in the example 1? Guys?
We remember.
You remember, all of you?
Yes.
Okay, maybe let me take one example in example 1 and then you do the rest. Okay, so they say in example 1 on page 160, they say f of x is equals to x squared. And they want you to draw that graph. So what you remember the domain of the function, isn't it? We say that the domain of this function is x element of real numbers, or we said from negative infinity to positive infinity, isn't it?
Yes.
That is why in the table they chose the x, the positive values as well as the negative values. So then you choose values and substitute in f of x. So they chose 0. They chose 0. They chose negative 1/2 and positive 1/2. They chose negative 1 and
positive
1. So basically they chose positive 2 and negative 2. That's how they write plus or minus, and positive 3 and negative 3. And then they substituted. So you substitute 0 in this function, you get 0. You substitute 1/2 in this function, you get, sorry about that, what's going on? 1/2 in this function, you get 1/4, 1/4. And then you substitute 1, you get 1. You then get 4, and then you get 9. Are we all together there?
Yes.
And then you go and plot your points. Right? So we know that 0 is here. So that's where you put your 0. And we know negative 1 and negative half is there. Let's say negative 1 is here. Negative 2 is here. So negative 3 is here. So we have, okay, let me put it like this. Negative 3 here, negative 2 here, and negative 1 here. And we know negative half will be somewhere here. And then we have 1, we have 2, we have 3, and somewhere here will be a half. So now points x is 0, y is 0, we are here. If your x is 0, y is 0. If your x is negative half, here's the negative y, half. Let's say y is 1/4. Let's assume 1/4 is here. So that point will be there. And they say if x is positive half, it will be here. Right? Now, if x is negative 1, then you'll be at 1. So 1 is here. So it's f is what? Negative 1, it will be here. If f is x is positive 1, it will be here. If x is positive 2, then y will be 4. It will be there.
Sure.
So that's how you plot your points. And then you draw it.
Yeah, mom.
You combine these points.
Yeah.
Do you see that, guys? Hi, guys. Did you see that?
Yes.
Yes,
Yeah.
Thank you. Now, when choosing point, the reason why I wanted to do this exercise is that when choosing point, you look at the domain. What is the domain of g of x equals to x to the power of 3? What is the domain of that? Guys?
X is the element of all real numbers.
Thank you. So meaning that when you're going to choose, you need to choose the positive part as well as the negative part so that you can have a good representation of the graph. Are we all together?
Yes, ma'am.
Thank you. Now, this graph over here. What is the domain of that function? Guys, what is the domain of that function?
X should be greater or equal to 0.
So meaning that when you choose values of x, you should start from?
From 0.
Thank you. Do you see that? Because in our high school, we're just choosing values. And then you put in sign, and they even show you how to solve using a calculator. You put in sign, it says error. It's because we didn't know the domain. Now that we know the domain, we say, okay, we mean we're going to choose only what? Only positive, from 0 and positive values. Are we all together now on when do you what values you choose and how you choose them?
Yes.
Depends on the domain. Thank you. Now on page 161, graphing functions with a graphing calculator. We're not going to do that. So you can skip it and scratch it out. It will not be in the exam.
Page what, ma'am?
That is page 161. For it might be different from the new book, new version, but it's called graphing functions with a graphing calculator. We're not doing that.
Okay, ma'am.
Right? Are we all together there?
Yes,
Are we
ma'am.
all together? Okay, thank you very much. So now let's go to, what's this? Graphing piecewise functions. We are back to piecewise function, guys. This is in your exam, in your, what do you call it? It's in your assignment. So listen and listen carefully. Now remember, we had words and we moved the words to the step function. Now we have a step function. We want to move the step function to the graph. So f of x is equal to x squared if x is less or equals to 1, and 2x plus 1 if x is greater than 1. How would you draw this one, Gareth? How do we draw this one, guys? You said you know how to draw graphs, isn't it?
Yes, ma'am.
Yes. So how would you draw this one?
Shouldn't we list the values that satisfies our criteria?
How are you going to do that? Oh, you said you know how to draw the graph. How are you going to do that? Because this is one of the questions, I think, if I remember.
So remember, I think we check about for the domain. So let's say for the domain of x squared, we have to understand that there's a condition where it said x has to be less than or equal to 1. So everything that
that's
is
a new domain.
Going backwards is what satisfies first part.
Yes. So how do you draw it here? Let me make space. So we have f of x equals to the step function x squared if x is less or equals to 1, 2x plus 1 if x is greater than 1. How do we draw this, guys? Is there someone who's like me? I can draw it, I'm 5. And we can close the class.
Then we look at interval notation.
Okay. Me, I'll draw a Cartesian plane because I'm ready to draw. I don't know how to draw, but I'm ready. I want to draw. I want to draw.
Our interval notation says from negative infinity to 1 included. So we have to draw a parabola that satisfies a positive number, which is a smiley face.
Okay. So you're saying we draw it?
We draw it from negative infinity up to 1.
Then
we look at the interval notation of 2x plus 1.
Then
2x plus 1 should be greater than 1. So
5 seconds. 5, 4, 3, 2, 1. Why is it taking your time now?
I was just drafting it up. X should be greater than 0. So it means from 1 should be greater than 1 up to infinity, up to positive infinity.
Good. Did you understand what he said, guys? Okay. Who doesn't know how to draw this parabola? Here. Do you all know how to draw this parabola? Let's start there.
Yeah.
We know how to draw the parabola, isn't it?
Yes, ma'am.
Let's draw it.
The way it is, let's forget about the intervals.
From negative infinity up to 1.
We are together, isn't it?
Yes.
So let's assume we're drawing and then we call this point 1. This was a point, and this one was 1 as well. And then maybe this one, let's say maybe you use point method. This is 2, so this will be 4. And then I'm just saying we used that method. Are we all together, ne? So far?
Yes.
Thank you. Now, let's draw this one. Where would it cut?
It's a straight line, so it starts from 1 to infinity.
No, don't focus here. We are only drawing the graphs now. These two first.
Oh.
Let's draw this one. You remember how to draw a straight line, isn't it?
Yes.
Let's draw it. Guys, what is the y-axis of this cement? What is the y-intercept?
1.
1. What is the x-intercept? Guys, what is the x-intercept?
0.
It can't be 0.
1 over 2.
1 over 2, thank you. So let's say we're drawing, okay, my one is here. So now let's join this graph. It cuts at half, ne? And then it goes like this, isn't it? Hey, yeah, it's a straight line, guys. So this one is 2x plus 1. And this is x squared. Are we all okay up to that point?
Yes,
so we drew our restrictions. Ne? We drew our graph. Let's go to our restriction. So the graph says for all x values, isn't it? That are less than 1. Are we all together? Guys,
yes,
are we all together there? We are drawing the restriction. So meaning that we go to 1. There's 1 here. Let me change a color. There's 1 here. You see where 1 is?
Yes, ma'am.
The x values on this graph, are they to the right or to the left? That will satisfy the statement.
To the left, we have to erase, or to the right, we have to erase them.
Thank you. So it means we are focusing here. This is our graph. This is our graph. Up to 1. Do you see that? Meaning that we'll take a rubber and erase that part. Do you see what just happened?
Yes, ma'am.
Guys, I need 3 yeses.
Yes.
Thank you. Now we go to the second restriction. Choose a blue color. The second restriction. It says, where do I start? At 1, isn't it? So the 1 is here. X is equals to 1 is somewhere here, right? When you substitute 1 here, what do you get? You get 3. So it's somewhere here at 3. 3 and 1. So it's here. Do I go to greater than or less than? Do I go up or down?
You go up,
but
you exclude the 1.
Thank you. You exclude the 1. So meaning that
open.
Thank you. So it will be an open curve there. Let's do that. So you exclude the 1. So it will be an open curve here. And then you go up because it says greater than. All x values at this side and not this side. So you go up.
And then you erase the remaining graph, which is the red one. So this is your graph then. It will look like this, but drawn nicely. Are we all together? So this is x squared on this interval. This is 2x plus 1 on this interval. Are we all together, guys?
Yes.
I want you to go and try example 7. That is changing from words to a step function to what's this? To a graph, where you have to move from words to step function, then draw the graph. Now, this is one of the functions that we normally consider. What do you call this? This is an absolute value function, and it is defined as x if all your x's are positive, 0, and then negative x if your all x's what?
Less than 0.
If your x's are less than 0. Meaning they are saying that if your x are positive are greater than 0, your function will be y equals to x, right? If your x are negative, your function will be y minus x. Are we all together there?
Yes.
Yes, ma'am.
Now, if we remember properly, when we draw y is equals to x, we would have a function like this that cuts but moves like this. Do we remember that? Yes or no?
Yes, ma'am.
Now, if we have a function like this, then the function was decreasing like that. Sorry. Let's write it like that. So this is y equals to minus x. Are we all together?
Yes.
Yes, ma'am.
But because if you substitute the values in the x values, whether positive or negative, in the absolute value, they will always give you a positive y value. Do we all agree?
Yes, ma'am.
So meaning that we'll only consider the top part. So this disappears. And this over here is called an absolute value function, which is represented by y equals to absolute value of x. Guys, are we all together?
Yes, ma'am.
Thank you. What is a vertical line test? We are finishing now. What is a vertical line test?
It's when you test if it is a function or not.
Okay, and then when is it a function?
When it touches once.
Yes?
When it touches once.
What's it once? Remember, let's do the relationship. You read a vertical when it touches one. So a vertical line test, good. It's when you draw a graph like this. Let's say this is your graph. Eh? A vertical line is a line that moves from up to down. A horizontal line is a line that moves from left to right or right to left. So what means that if you draw any line in this graph and it cuts the graph once, then it's a function. But in this case, a second is not a function because it cuts the graph twice. Do you see that? It cuts here, 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 it cuts there. Are we all together?
Yes, ma'am.
Thank you. Now, this goes hand in hand with what we have learned. We say that in A, domain, B, range, the value of x should only have one y value. One y value. One value. Meaning that if you draw a parabola, for example, like this, if you choose a value of x here, and it will have one y value. Do you see that? This relationship is also represented in a vertical line test. Here, choose an x, one y value. Choose an x here, 1 y value. Choose an x here, 1 y value. Are we all together?
Yeah.
So that is example 8. And then which equation represents a function? Now, on example 9, they say, okay, fine, you are given y minus x squared is equals to 2. And you are given, that's A, and you are given B, which is x squared plus y squared is equals to 4. And they ask you, which one is the function there? So when they ask you which one is the function, so they just mean that represents whatever you see with respect to y, x. So meaning that here we have y minus x squared is equals to 2. So then y is equals to 2 plus x squared. So meaning that if I take any value of x here, I'll get 1 y value, isn't it?
Yes, ma'am.
I put 1 here, I'll get 1 y value. So therefore, this is a what? Is a function. Are we all together?
Yes, ma'am.
Now, let's write y squared equals to 4 minus x squared. Y is equals to the square root of 4 minus x squared. But remember, when you take a square root, it's plus or minus. Do you see that? Are we confused or are we together? Guys? Are we together or we're confused?
We're together, ma'am.
How many togethers? And the last together? Thank you. So meaning that here, you'll get 2 values here. So meaning that if you put an x value here, you'll get a positive of the answer and a negative of an answer for the y value. Do you see that?
Yes, ma'am.
Yes.
Therefore, this is not a function.
Function.
Thank you. And then on page 166, they say some of the function in the graph. They'll tell you the power function, the root function, the reciprocal functions, and the absolute value functions. Those functions are all there, and we'll do them later on. But just have a look at them. You see, and if you have any question, just shout, and I'm here. Any questions for now? Right, any question?
No, ma'am.
Okay, I think then that's it for today. And you can go try to do exercises and then go to the assignment and do the question that's related to the work we covered today.
Thank you.
Thank you so much, ma'am.
Thank you so much.
Thank you.
Thank you.
Thank you. See